Hi everyone, now we are performing an experiment that is resonance in LCR parallel circuit. That is, here the parallel circuit I have already made the connections as for the circuit. Before, before that, let me explain the aim of the experiment. That is, to set up an LCR parallel circuit and study the resonance and determine the resonant frequency for the circuit and determine the quality factor Q for the two different values of the resistance. The two different values of the resistance are one is 50 ohm and for the 20 ohm. That is, and the formulas are for the resonant frequency F naught is equal to 1 divided by 2 pi into root of LC, that will be in the order of hertz, and for the bandwidth, that is delta F is equal to F naught minus F1, which this is the difference between the highest frequency minus the lowest frequency, and quality factor, that is omega naught L divided by R, that is where omega naught is equal to 2 pi F naught into L divided by R, where quality factor is defined as the sharpness of the resonating curve, or this is the inductive reactance or capacitive reactance with to the applied resistance, and the circuit is the AFO is connected here, and this is for the millimeter positive and millimeter negative, and again that is connected to the resistance R, and the these capacitor and the inductor are in the parallel, where this joint is connected to the resistor's word terminal, and these two are connected, inductor L and the capacitor are connected here, and this again this terminal is connected to the AFO's another end, where C is the capacitor and L is the inductor, R is the resistance box, where AFO is the audio frequency oscillator oscillator, and MA is the milliampere, and the nature of the graph is as shown here. When the current is high, that is the when frequency is very low, the current will be high. By gradual increasing the frequency, one sudden time the current will minimizes, it will be in the minimum order, and again by increasing the frequency, again its current will be increases. It will be determined by experimentally. I will show you how this comes. And the observations, this inductor of the 50 millihenry, that is the inductor is of the 50 millihenry, here we can see it, and capacitance of 1 microfarad, here the capacitance is 1 microfarad, here we can see it 1 microfarad, and resistance is for the 20 ohm and 50 ohm. By plucking the keys of the 20 ohm, now it's for the 20 ohm, and by making it for the 50 ohm, it will be at the 50 ohm. Then as per the circuit, I will show you the connections how I have made. From the AFO, one terminal connected to the milliammeter, here one terminal connected to the milliammeter, and another terminal connected to the junction between the capacitor and the inductor. This is a junction between the capacitor and inductor. I have made connections, and again one terminal is connected to the capacitors another end, and the resistors another end, and inductors another end. These three connections, one is from the capacitors another end, another one is from the this is from the resistors end, then this is from the capacitors end, and this is the inductors end. Then the negative key is from the resistors one end. So before starting the experiment, let me turn on my experimental setups. So now by turning on, what I need to do is, first we have to set for the peak to peak voltage, that is VPP. This should be equal to 2 volts. So by using this knob, we can set for the voltage. In my previous video, I have already told about how to operate the function generator. So now I will not explain you much about this one. So what I need to do is set it for the 100 hertz. We have to use it very carefully. Then 95. Now use the fine knob. Don't be hurry while setting it. Now for the 100, it's showing that now by plugging 20 ohms for the 20 ohm resistance, this is showing 4.8. Now for the 20 ohm, the applied frequency is 100 hertz and current showing 4.8. Now increase for the 200. 200 it is 0.43. It is for 200 4.3, and for 300 and this is for 300, that is 3.5. For 300 3.5, then go on for the 1000 hertz, then 1100 hertz, then for the 2000 hertz. And note down here approximately for the average values I will show how much this is the decrease value, that is when it will become the almost zero by increasing the frequency. This is for 12 kilohertz. For the 12 kilohertz it is 0, almost 0. And then now again it will increase. Then note down for the around for the 50 ohms, that is by taking the 50 ohm resistance. Now it is for the 50 ohms, and then what we need to do is just for taking the 100 ohms, sorry, 100 hertz, 100 hertz it is 4.1. For frequency 100 hertz this is 4.1 milliamps. Then go on for increasing 1000 hertz, then 2000 hertz, here 1100 hertz. Then take readings up to when it will be in the order of gradually decreasing and later increasing. Again when I plot a graph of it, it will be look like this one. This is for the 20 ohm, this is for the 20 ohm, and this part is known as the I minimum, this part is known as the I minimum. This is into root 2, and these are the highest cutoff frequencies. Then this is for the 50 ohm, this is for the 50 ohm. The graph will look like this one.